Hello students and everyone, once again welcome back into our lesson video. So in this lesson video we're going to be touching on Newton's law of universal gravitation. As you know, or as you possibly know, that we have discussed Newton's laws of motion, Newton's first law, Newton's second law, and Newton's third law. And today we are going to be looking at Newton's law of universal gravitation. Okay, obviously looking at some of the calculations, and if ever you are new to the channel, please don't forget to subscribe. Please don't forget to share the lesson video or the lesson content in this YouTube channel. Yes, thank you so much. So let's get into this lesson. Okay, so yes, so guys, having discussed Newton's laws of motion, this incorporates Newton's first law, Newton's second law, as well as Newton's third law. So when speaking about Newton's law of universal gravitation, you can see that it's clear to see that we're going to be looking at more and more on gravitational force, okay, or forces that have something to do with gravitational force. Okay, yes, so this also emphasizes that when I'm wrapping it up for you, this also emphasizes the fact that Earth is pulling all the objects downwards or towards itself. Okay, yeah, so there is a force that is pushing or pulling all the objects to the Earth's surface, or attracts all the objects to the Earth's surface. But the most vital point that I want to make is that Earth always pulls us downwards, or always pull the objects towards itself, or attracts the object towards itself. Okay, so what does Newton's law of universal gravitation state? So Newton's law of universal gravitation states that every point mass attracts every other point mass by a force directed along a line, okay, that is connecting the two. So meaning that we have maybe an object here, okay, and we also have an object here. These are two different masses, okay, as you know that obviously objects have different masses or have masses. So this basically means that this object is attracting this object, okay, yes, by a certain amount of the force of attraction. So we're going to be also calculating more and more of the force of attraction and okay, so Newton's law of universal gravitation states that every point mass attracts every other point mass by force directed along the line. Connecting the two, okay, connecting a two. Okay, so this is not the end of it, guys. I just want to make it sure that you understand what is being stated by Newton's law of universal gravitation. So say that every point mass, as I made an example, okay, between 2 point masses, so attracts every other point mass by a force directed along the line, okay, between the two. Okay, so that force, okay, that force of attraction, I can say, or the force is proportional is proportional to the product of masses, and inversely proportional to the square of the distance between them, okay, or between the two. Okay, so yes, I told you that it's not okay, so understand please. So the force is proportional. This basically means that the force is proportional. Okay, so we have this instance here, we have this, let's say this object here and this object here, okay, yes. So this object, okay, is attracting this object, okay, yes. So they attract each other by a certain amount of force, okay, yes, along what? Along a line connecting the two or between them, okay. So mind you guys, the force must start from the center of the objects, more especially to bigger object or huge objects such as the earth, okay, yes. So they attract each other, okay, yes. Okay, so this is the distance squared between them, okay, yes, in order for us to determine the force of attraction. This is the mass, this is mass 1, and this is our mass, this is our mass 2. What's the thing? Okay, so you also have, okay, the gravitational constant, okay, also have the gravitational constant, okay, yes, which is equals to what? Our gravitational constant is equal to 6,67 to the power of 10. It's also 6,67 multiplied by 10 to the power of negative 11. Okay, so that's our gravitational constant, meaning that it's always constant each and every time. Okay, so meaning that force of attraction that we are talking about, okay, that's the force that's acting between these two masses here, okay, the force of attraction. Okay, let me just remove a little bit so that everyone can see. Yes, so the force of attraction, okay, will be equals to what? The gravitational constant and the product of the masses, okay, mass 1 and mass 2, over d squared, the square of the distance between them. I can say square of the distance between them, and this becomes our formula. As you know that our force was proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay, so this is our formula that we are going to be using when calculating the force of attraction. Okay, yes, that's acting between two objects. Okay, so guys, let me make an example, okay, when calculating these instances. Okay, so when calculating the force of attraction, okay, let me make an example. Let me create my own example. Okay, let's say we have the object here. Let's say we have a stone here. Okay, let's say this is the object. With this object, okay, this object is bigger mass. Let's say this is 90 kilograms, and this is 30 kilograms. Okay, this is 90 kilograms, this is 30 kilograms. You can see. So you know that there's a force of attraction between these two points of masses, okay, between these two from here to there. So let's calculate the point of attraction between the two. Okay, so what's the distance between them? The distance between them, let's say it's 15 so sorry, let's say it's 15 meters, okay. Let's say it's 15 meters, so the distance between them is 15 meters. So we have 15 meters, okay. Right, so let's use our formula to calculate or determine the force of attraction. So you know that F is equals to the gravitational constant mass 1 multiplied by mass 2 over d squared. So this will be equals to what? This will be equals to what's gravitational constant? It's 6,67 multiplied by 10 to the power of negative 11. Okay, so what's our mass 1? It's 90 kg multiplied by what? Multiplied by our mass 2, which is 30 kg over d squared. What's the distance between them? It's 15 meters. That's going to be 15 squared, okay, 15 squared d squared, okay, the distance, okay. Yes, so this will be equals to what? So press that on your calculator. Let's press that on our calculator. Okay, so what I want to tell you guys is that just to tell you, we have to apply, okay, we have to apply calculator skills right now. Okay, look, so we have to set your calculators. If you ever maybe using Casio or any kind of a calculator, that is a scientific calculator, okay. Yes, so you have to press shift. You have to turn your calculator into scientific mode, okay. Press shift and press mode. That is going to give you 8 options. So the 7th option is the scientific mode. So press 7. After pressing 7, you're going to see 0 to 9 and press 3 so that you can round off to 2 decimal places, okay. Yes, so press that in your calculator. 6,67 multiplied by 10 to the power of negative 11 multiply by 90 close bracket and open bracket, 30 close bracket, 15 squared, and that gives us 8,00 multiplied by 10 to the power of negative 10. Okay, so that gives us 8,00 multiplied by 10 to the power of negative 10. Okay, yes, that's a very, very small force there. Okay, force of attraction between the two is very, very small. Okay, but I'll explain about that one later. Yes, if ever you are going to be able to remind me, I was going to say, please remind me, guys. Okay, yes, so that's our answer. Okay, the newtons. So sorry, newtons. Okay, please let's not forget the units, guys. Okay, that's a force, okay, measured in newtons. No. Okay, so what else right now? So let's stick on our calculator skills. Look, maybe some of you are finding it hard to put that in their calculators. You can just press 6,67 multiply by 10, okay, multiply by 10 to the power of negative 11, and press it like this. I hope you can see that. Yes, so after that you can put multiply, okay, you can press multiply that, because that is multiplying with our fraction there, okay, and put a fraction. Okay, after putting a fraction, you can also open bracket and put 90 and write down that on the board as it is. Okay, 30, that's 15 squared. Yes, that's 15 squared. Press equals to, that is equals to the same answer. Okay, 8,00 multiplied by 10 to the power of negative 10. Yes, that's a very small force. Okay, yes, that's a very small force. So that was an example. Okay, let me explain about what I said I was going to explain to you. Look, because that is a very small force. Imagine, okay, this is like 8 multiplied by 1 over 10 to the power of 10. Okay, so that's a very small force. Okay, this is like if I'm applying my mathematical skills, this is like 8. Okay, this is just an example, guys. Like 8 multiplied by 1 over 10 to the power of 10. Okay, yes, so that's a very small number. Okay, yes, I was going to also say you can check that on the calculators. Okay, just give me a little bit. Okay, yes, so it's a very small force, 0,000 something. Okay, that's a very small force of attraction that you have there. Okay, so this was just a mathematical representation of your answer to prove that it's a very small force or small magnitude of force. Okay, look, so you see the distance is 15 meters. Okay, it's 15 meters apart. But if ever we can either increase or enlarge, making it wider, meaning that you're enlarging the distance, maybe we have 20 meters apart of these two objects, the force of attraction will be smaller, will be very smaller. And that basically means that the longer the distance between objects is the smaller the force of attraction, and the closer the distance is, or the shorter the distance is stronger the force of attraction between those two objects. Okay, yes, so I think I've nailed that one. So if ever maybe we say now it's 8 meters, 8 meters become closer, these two objects, so the force of attraction will increase. Okay, yes, but it's not going to be that larger. Okay, yes, it's going to be at least again be a very small force. Okay, so I have an example for you. Okay, let's work on this one. So this is one of questions that I took from my materials. Okay, it's just doing this. Okay, so hope everyone can see. Okay, so this says that okay, so we have a man. Of mass 80 kg. Of mass 80 kg. Standing 10 meters apart. 10 meters apart from a woman. With a mass of 65 kg, 65 kilograms. Okay, so calculate the attractive gravitational force. So let's calculate there. So calculate the attractive gravitational force. Gravitational force. Okay, so what is calculate the attractive gravitational force. Okay, yes. Yeah. So let's answer. Right now. So these are answers. So F is equals to gravitational constant, the product of the masses over d squared, distance between them. Okay, so this will be equals to 6,67 multiplied by 10, our gravitational constant, to the power of negative 11. This is multiplying with this. Okay, yes, you can just put a big bracket if ever you want, but you can also just put this, okay, just to show this is multiplying with this fraction. Okay, okay, so sorry, m1, so the mass of the man is 80 kg. So sorry about this. So 80, close bracket, open bracket, multiply by the second mass of the woman, which is 65 kgs, over the distance squared. The distance between them was 10 meters. It's going to be 10 to the power of 2. Okay, yes, so that will be equals to, you might please press that in calculator. Okay, let's press that on our calculators. Okay, that is equals to 3,47 multiplied by 10 to the power of negative 9. That's equals to 3,47 multiplied by 10 to the power of negative 9 newtons. Okay, that's our answer there. Don't forget the units, guys. Okay, yes. So yes, I hope you received the very same answer, guys. Yes, that's how it goes, straightforward, and that's how it is. Okay, so let's move to the second example. Okay, yes, let's move to the second example so that we can do more examples by your own, guys. Yes, okay, you can do more examples by your own. Okay, let's do the second example. So it's going to be okay, let's say, okay, now let's consider this one, the gravitational force between the earth and the moon. Okay, let's consider the gravitational, the mass of the, so this was the first one, this is the second one. So the mass of the mass of the earth, the mass of the earth is what? Is 5,98. Is 5, okay, let me just write it here. Is 5,98 multiplied by 10 to the power of what? By 10 to the power of 24 kg. Okay, yes, so this is the mass of the earth. The mass of the moon is 7,35 multiplied by 10. Okay, is the mass of the moon is 7,35 multiplied by 10 to the power of 22. Okay, kg. Okay, the earth and the moon are 3,8 multiplied by 10 to the power of 8 meters apart. The gravitational force between them the gravitational force, okay, or calculate the gravitational force acting between them, acting between. Okay, that's how it goes. So right now let's calculate the gravitational force acting between them. So the mass of the earth is 5,98 multiplied by 10 to the power of 24 kg. The mass of the moon is 7,35 multiplied by 10 to the power of 22 kgs, and the earth and the moon are 3,8 multiplied by 10 to the power of 8 meters apart. So calculate the gravitational force acting between them. Okay, yes, let's calculate. So for our answer, this is going to be like this. Let me just pull that one upwards. So force is equals to gravitational constant, the product of masses over d squared. The square of the distance between them is equal to 6,67 multiplied by 10 to the power of negative 11. What's mass 1? Mass 1, which is the earth, is 5,98 multiplied by 10 to the power of 24. That's the earth. What's the moon? The moon is 7. The mass of the moon is 7,35 multiplied by 10 to the power of 22. Okay, that's over. What's the distance? And the earth and the moon okay, the distance is 3,8 multiplied by 10 to the power of 8 squared. Okay, yes, squared. So that distance between them, because they are apart to that distance. So that's equals to, press that in calculator. Let's press that in calculator. 6,67 multiplied by 10 to the power of negative 11. Okay, open brackets, close brackets. Okay, press that in calculators also, guys. So sorry, that's equal, that's the power of 9, right? No, that's power of 8. Yeah. Oh yes. So divide by 3,8 multiplied by 10 to the power of 8 close bracket squared. Yeah, so that gives us 2,03 multiplied by what? 10 to the power of 20 Okay, you can see that 10 to the power of 20, it's a big number. It's a very big number. Okay, so when you multiply 2,03 multiplied by this number 10 to the power of 2, it's a huge, very big number. You can't even mention. Okay, so the force, okay, you can see that right now the force is not small. Okay, yes, it's not relatively small, I can say. So if not, the reason why it's that the objects are now bigger. Okay, we are talking about bigger objects, or with objects that has a very big mass. Okay, yeah, so you know that the earth and the moon has bigger forces, bigger masses, which will result in huge or very great gravitational forces between them. Okay, yes. So if you ever maybe take objects like a stone, as I made an example, small stone, a rock, you can say. So very small objects. Okay, yes. So that is going to result in decreased gravitational force acting between the two rocks, for example, as well as human beings. So the forces again are very small. Okay, yes. Okay, so that's how it goes. So in all, I can say that the greater the masses is, the greater the forces between them, and the closer, as I explained, the closer the bodies, okay, yes, the closer the bodies, for example, is the stronger the gravitational force between them, okay, yes. Okay, right now let me make an example of this gravitational force, okay, of this what I'm talking about. So let's say we have a building that is a tall building that is 100 meters apart, okay, from the earth surface. So this building is 100 meters tall, okay, yes, 100 meters tall. So if this building is 100 meters tall and there's someone standing here, okay, let's say there's someone here wants to jump, okay, they want to jump, or they are standing here, or they want to jump, let's make an example. And next to this building we have a very tall building, okay, that is 5,000 meters, and there's someone here, make an example. So they want to jump, or they are here, they are position. So this person here, after jumping, okay, or even at that point, as compared to this person is experiencing more gravitational force, okay, more gravitational force, meaning that the gravitational, as well as the gravitational acceleration, is equal. Or I can say that this person is experiencing more gravitational force, or more gravitational acceleration, or more gravitational force, I can say, okay. The force of attraction means that the earth is pulling this one downwards more, okay, yes, by 9.8 meters per second, you know. So this one here at the top of this building is also experiencing, yes, maybe but it's very, very tall. Let's say maybe this one was on the space, okay, there was less gravitational acceleration acting on that person, pulling it downwards, meaning that if ever you're very, very far from the earth's surface, or from the earth, that basically means that you're experiencing less gravitational acceleration, okay, or meaning that the earth is in terms of pulling you downwards is doing that in less forces, okay. But if ever you're very close to the earth's surface, earth is pulling you very, very quick and with high forces, okay, yes. I hope you did understood that one. Okay, so let's talk about objects right now. Okay, so we have this object here, they are on the same position. This object, this is let's say this is 50 kg. It's in the air, it's being pulled by earth, you know. So this is 30 kg, the masses. So the mass of this one is equal to 50, and the mass of this one is equal to 30 kg. So they're flying down, meaning that they're being pulled by earth surface, by the earth downwards. So they're accelerating with what? With 9.8 meters per second, okay, the gravitational acceleration, 9.8 meters per second. Okay, so the position is the same, okay, the position is the same. If ever the position is the same, this basically means that, and these two objects were dropped at the same time, they're going to arrive into the earth's surface at the very first, or at the same time again, so sorry, at the very same time. So they are going to arrive on the earth's surface in the very same time to these positions. But there is a difference on forces, because there's a force of gravity that's acting on this mass here, as well as this object here, as well as this mass, okay. So Why there is difference? Because you know that the gravitational force is equal to mg. So the force that is acting on that 50 kg is 50 multiplied by 9,8 by the gravitational acceleration. This is equal to, press the calculator, 50 multiplied by 9,8 is equal to 50 multiplied by 9,8 is equal to 490 newtons. 490 newtons. That's the gravitational force acting on that 50 kg. So the gravitational force acting on that kg is going to be huge or bigger than the force that is acting here on 30 kg. Let's look at 30 kg. You know that Fg is equal to mg. So 30 multiplied by 9,8, this is equals to 30 multiplied by 9,8 to 294 newtons. 294 newtons, as you can see. Okay, that 294 newtons is less than 490 newtons. Okay, yes. So I just wanted to explain that. Okay, yes. Okay. Okay, right now let's talk about the mass and the weight. Okay, many people confuse mass and the weight. They don't know which is which. Okay, let's talk about mass and weight. Okay, when speaking or talking about mass and weight, what is a mass? So you should know the definitions, very important. They are going to be asked during exams, or they can be also asked in a different way, but it's a vital concept to know. Okay, so a mass is the amount of matter in a body. So a mass is the amount of matter in a body. So that's a mass. So a mass is the amount of matter in a body, meaning that if ever I take let me say I take grains of rice. Okay, or I take grains of rice and I pour into a plastic. That plastic suddenly have mass. Okay, yes, it's now having a mass of maybe 2 kgs, 2 kilograms. Okay, yes, so that's the amount of the matter inside that plastic. That's the amount of the grains of the rice grains inside that plastic. I'll just make an example. So we have a mass right now. So when talking about a weight is the product of the gravitational force. Okay, this is the product. So sorry, not of the gravity. So the weight is the same as the gravitational force, because the weight is equal to the gravitational force. So the weight is the product of the mass and the gravitational acceleration. Okay, so in other ways I can just say weight is the gravitational force exerted on the object by the earth. Okay, so that's the weight. So weight is the gravitational force. So this is gravitational force exerted on an object by the earth, and that's how it goes. So that's a weight. Okay, so weight is the gravitational force exerted on the object by the earth. Okay, that's the weight. So the difference between the mass and the weight is that one. So I hope you can understand and see that guys. So let me make an example. Let's say we have this person here. So this body, so this person, I can say this person. So this body here, let's say they are on a scale. So again, many people, they like to confuse. So when you're in a scale, you are checking your mass. You're not checking your weight. You can't have your weight. Okay. Yes, you're checking your mass of okay, or you can just say you're checking of how much you weigh, meaning that how much gravitational force acts on you. So you're looking for the gravitational force that's acting on you. Okay. Yes. So this person, let's say this body is 60 kg, right? Yes, 60 kilograms. Let's say it's 60 kilograms. And if there are 60 kilograms, okay, using the scale, so this is the scale, the mass scale, okay, so this is the scale, okay, so that's the scale. So if ever they check their weight, okay, they are going to use their eyes to check the weight, okay, so the weight will be written here. You know the scale, guys. So when checking the scale, I think you can be able to calculate their own scale. So the scale of this human being here will be of this body, I can say. So will be, you know that weight, Ft is equals to weight is equals to mg. Okay, yes. So what's the mass of that? Okay, so yeah, so the mass is 60 kg, as I told you that the mass of that is 60 kg multiplied by the gravitational acceleration. So what's the weight? Let's check the weight. Will be 60 multiplied by 9,8. The weight will be 588 kilograms. That's the weight. Okay, yes, that's the weight. So when they look for that, I mean that they are very, very huge and big. Okay, so I can also make an example, another example in a vice versa way. So let's say this person is now, let's say in this instance, we have this body here that is weighing on a scale, meaning that their weight, let's say their weight is 72 on the scale. It's 72 kilograms. Okay, so this is their weight. So their weight is 72 kilograms. Okay, so so weight will be, so now right now let's determine their mass. Okay, so 72 kilograms is equal to mass multiply with gravitational acceleration. So when I look at this, I exaggerated on that one. Okay, maybe I was supposed to say maybe the weight is 60. So so what's the weight? Weight is 72. So sorry, weight is 72. You're checking for the mass multiplied by gravitational acceleration. So 72 is equals to 9,8 meters over 9,8 over 9,8, and therefore our mass, his or her mass will be equals to 72 divided by 9,8. This cancels this, so we have to mass, so 7,335 kilograms. So that's their mass. Okay, yes, that's their mass. So their mass is okay, as well as the weight is not exaggerated. Okay, so sorry about that one. Okay, yes, because I really wanted to make a scenario which is going to be more relating to the real world scenarios. Okay, so that's the end of our lesson for the day. See you in the next following lesson video. Thank you so much. Cheers.